Alrighty, so for this example, there's a lot going on here. I'm actually going to ask us to do a little bit more than is already on there. So it says identify the following key features of the graph: max, min, x and y intercepts, and behavior, increasing and decreasing intervals, and the domain and range. There's a lot going on here. We're going to try to take this piece by piece. One couple things that it didn't ask you to do, but I'm going to have us do anyways. I want us to identify the degree of this function and the leading coefficient. So the degree of this function is 4. The highest exponent that we have is x to the 4th. So it's 4, which means it's an even number. And then the leading coefficient is 1. Now, I don't see the number 1 written there. Remember, if there's no coefficient in front of a term, that means it has a coefficient of 1. So you could pretend that there was a 1 in front of here. It means that would just be, let me zoom in, that would just be 1 times x to the 4th. We don't need to put the 1 there, but it's helpful to realize that it is there. Again, we don't need to put it there because it's kind of like me writing my name as 1 times Mr. Brasser. There's just one of me. Well, there's many Mr. Brassers, but there's just one of this specific Mr. Brasser. Thank goodness, right? But anyways, so leading coefficient is 1. It is positive, and kind of following along with some of the patterns that we've been talking about in the previous page. This has got that shape, and let me highlight that with this tool. It's got that shape. It's got kind of a U shape. Actually, maybe this is a W shape because it's got the little bump in the middle there. But it goes down, and then back up. Both the right side and the left side over here, even though this graph did a poor job of labeling it, they point up. Both sides are pointing up. Remember, when both arrows point in the same direction, the left and right side, sorry, this is your left, this is your right. So on the left and right side, if they both point up or they both point down, it's got to be an even degree. Since they're both pointing up, it's got to be positive. Going through, let's talk max and min. Now, there's several different max and min points. I'm going to refer to them as relative or local max and min points, kind of like we talked about when we were with the definitions. The min points, let's just at least label those to start, and then we're going to use a calculator to figure out the specific points. So we got a min point right there. We got a min point right there. They're like at the bottom of a valley, and we got a maximum point over here at the top of a hill. Now, to figure out those exact max and min points, we're going to have to jump over to a calculator. So if you're using a Chromebook, feel free to use that the calculator app that we pushed out to you. I think it's probably right at the bottom of your screen already, but I'm going to use this one here. So I'm going to clear out anything I have in here because I've already been using it. So if you're not super familiar with it, I'm going to just kind of walk you slowly through it. So first, turn your calculator on. Now, to enter things into a graphing calculator in order to see the graph, we're going to use the graph button later, but for now we got to click y equals. So let's go to y equals. That's already where I am. Let me start over. Let me just get back. When you turn the screen on, it should look like this, or maybe it has some numbers in it. That doesn't matter. The first thing we need to go, again, y equals. Now, in here, we're going to go through and type out that function. Again, just a reminder what the function is. It's right here, x to the 4th plus 7x to the 3rd plus 12x squared. So I'm going to type that in, and I have to do this with even though I've got a keyboard here, I'll have to do it with my mouse. We got x. The X button right next to the alpha button. You see it says XT, that's a theta, and that's an N. By clicking that, it'll automatically plug in the correct variable for the situation. It knows we're supposed to be using X. We will use some of those, we might use some of those other ones later, especially the theta. We're going to focus on just the X. So we'll do X. Now, there is no to the 4th button. You'll see there's a to the 2nd button here. To get to the 4th button, we use this button. It's called a caret. So we go X caret 4. Now, if you're using a TI-84, like on the Chromebooks or in person, we have it'll automatically raise it up there. If you're using something that looks like a that's a TI-83, that caret symbol is just going to show up there, and it'll be like X caret symbol 4. It's not going to look like an exponent, but that's what that means. So we got x to the 4th plus 7x to the 3rd power. Press the right arrow to get out of the exponent. Then what do we got? Plus 12x, and then there is a square button, so that one's already built in, so I'll press that. So we got x to the 4th plus 7x to the 3rd plus 12x squared. And now let's take a look at our graph. So we're just going to press graph and see what happens. So that doesn't look exactly like the graph that we have, but That's because it's got a different scale. Let me go back to the graph that we were given. The graph that we were given, you'll see on the x-axis, it goes all the way down to -7 and all the way up to +3. On the y-axis, you'll see that tick mark down here, you can kind of tell, but it says 10. I'm guessing there's a negative there. But then up here it goes 10, 20, 30, 40, 50, 60, 70, 80. Now, on our graphing calculator, what this does is it only goes up. Each tick mark represents 1, so this goes 1, 2, 3, 4. It goes all the way up to 10. The x-axis goes all the way down to -10. The y-axis goes down to -10 as well and goes up to +10. If you want to change it, you can. If you want to change it to look like what we had on the other graph, what we're going to do is go to y equals to make it more exact or more similar to what we saw. So we'll go to window. The window tells us what minimum x value we want to use. Well, the one that we're given is, let me see if this typing actually works on here. -7 was the lowest value. Ooh, never mind, that's the minus symbol. Let's just type it like this. -7. The highest x value we saw on the x-axis was +3. The x scale, that just says every tick mark represents just 1. Now on the y-axis, our graph went down to -10, which is where we are. It went up to +80. Now the y scale we're going to change because on the graph it goes every tick mark represents 10 change on the y-axis. So let's change our y scale to 10. And now if you can ignore the rest of that. I don't think we'll ever use that in this class. I'm going to go back to the graph now. So again, make sure your window settings look something like this. So -7 to 3 on the x's, -10 to 80 on the y's. And we'll graph it. Now it's going to look way more similar to what we were given in our notes. So again, that graph looks pretty similar to that graph. Okay, so now we've got a graph. Great, we already had that. But we can use our graphing calculator to help us find those minimum points. So we got a minimum here, we got a minimum here, and we got a maximum over here. What we're going to do next is we're going to use the calculator to calculate it. You'll see up here. Sorry, class is over. Just kidding. Anyways, so the calc button or the calc option is up here. So in order to get to that blue function, we got to go second and then press the trace button so that it'll go second and use its second option, which is the calc. Now let's start off by finding a minimum. So let's choose option number 3. So you can either use the arrow, go down to option 3, hit enter, or you can just press the number 3 and it'll automatically do it. So what we got to pay attention to here is the directions that it's giving us. It says left bound. That means we got to move this cursor using our left arrow, and let's move it to the left of this minimum point over here. What we're going to do is we're going to hit enter, and that's going to say, okay, this is as far left as the graph is going to, or the graphing calculator is going to look. So now we're going to go right bound, and we're going to go to the right of that minimum point. So we've got to make sure that minimum point's in between the left bound and the right bound. We'll hit enter. So now this shows up really well in this calculator. It might not show up as on your calculator, but let me see if I can even zoom in. No, I can't do that way. But it's only going to look for the lowest point between this bar and this bar. So it's going to find that point. The last thing it asks you to do is guess. This is not the most useful, but if you, I would say just put it kind of close. It doesn't need to be that close to exactly where it is. But we hit enter, and it gives us the information that our x value at our minimum point is -3.568, etc. The y value is -3.123. Let's just round to 2 decimal places. So back in our notes, let me try that again. Back in, oh, my iPad closed down. Hold on, sorry. I'm not going to remake this entire video just because my iPad fell asleep. So try this again. That'll work. Okay. So again, that minimum point, we just found that point right there. So the minimum point, the coordinates are, and I'll write this down and you can copy it back into your notes as well if you're on a separate screen. So we have a minimum point at -3.57 comma -3.12. So again, in our notes, it'll look something like that. Now there is a second minimum point. Let's take a few seconds to find that. So if you recall, to get to that one, we're going to go second trace to get to that blue calculate menu. It might be a different color on your calculator. We're going to go down to minimum, where you can scroll down or just hit 3. hit enter there. Now we're going to find that one there. So let's just move it just so that's a little bit to the left of it and hit enter for left bound. And then we're going to go a little to the right of it. It's a little far, but whatever. So it's only going to look for the lowest point on that curve between these two bars. And put your guess, it's just got to be in the middle. I think the closer you are, the better it rounds. It's not a huge deal in most cases, to be honest. So we'll hit enter, and ooh, sweet. Look at those numbers. So one of them says 4.0203 e negative 7. Boy, what does that even mean? And then 1.94 e negative 12. Let me go to our notes and let me jot one of those down a second. This is going to be a sidebar. Let's do the 4.0283 e negative 7. And I'll be honest, folks, I was not planning on including this in this video, but it came up. So let's just learn it now, because you might encounter it if I'm not around. So there we go. Okay, so in our notes, I just wrote down one of those numbers, and you might encounter a similar number. If you don't, and you end up getting really nice numbers, good for you. I didn't. So 4.2083 e negative 7. That is the calculator's way of expressing something that looks like this. 4.0283 times 10 to the negative 7th. You might recognize that as scientific notation. Now you also might remember how to go from scientific notation to just a pure decimal, and that would be by moving your decimal place. So if it's a negative decimal, you would take that, or negative exponent on the 10, you take that decimal and move it 7 spots, or however big that negative number. So it's negative number, so we move into the left for you guys there, and then we'll move it 7 spots. So it's going to end up being 0.00000400283. Let me make sure I counted that correctly. 1, 2, 3, 4, 5, 6, 7. Yep, I moved the decimal place 7 spaces to the left. There we go. And it became 0.00000400283. Folks, I'm going to use a term that is by no means technical, but it's how I refer to numbers like this. I think this is a stupid small number. It's so small, it's stupid. Now, in most cases, we're only going to round to like 2 or 3 decimal places. So if we were to round this one to 2 decimal places, it'd be 0.00. That's 0. If we were to round to 3 decimal places, that'd be 0.0000. That's still 0. These calculators aren't perfect. They do rounding errors, but they're doing a best approximation. They're doing, really, from my understanding of how it's programmed, a very loose version of calculus. It's not doing a perfect version of calculus, that's for sure. But it's got some rounding errors, and effectively, we're just going to safely assume that it is 0. So let me go back to the graph. You'll see the 4.0283 is to the negative 7. 1.94 e negative 12, that means it's even smaller. It's going to have even more zeros before it even gets to that 194. So we're going to confidently say that the calculator is trying to tell us, even though it's doing some rounding errors, that the minimum point at this point here is 0, 0. Maximum point. The maximum point. We're going to go back to the calculator. Think about maximum and minimum. They're very closely related. They're opposites, but they're related. So we're going to go second trace, and we go down to maximum. So again, you can scroll down to 4. I'm just going to hit the number 4, and it automatically does it. So we're going to find the maximum here. We're going to scroll to the left and hit enter. So the left of that maximum, hit enter. Scroll to the right of that maximum, hit enter. Remember, we don't want to go too far to the left and right, because if we go to if we went all the way over here to the left, it would think it finds a point over here that's higher than that point. We want to only find in this area. Put your guess close-ish to it. And we got an x value of negative 1.68 and a y value of 8.64. Let's jot that down. Let me flip back to the notes. So we got maximum value at negative 1.68, and the maximum y value was at 8.64. Now, sometimes you'll be asked for min values. When you're talking about the minimum values, those are just the y values. So it would be negative 3.12 and 0. The max value, or the max local value, sorry, I'm off the screen. Let me shift that over. The max value would be just the y value at that highest point of 8.64. So those are our local max and local mins. Increasing and decreasing intervals. Increasing and decreasing, I'm just going to abbreviate as INC and DEC for decreasing. So let's do increasing intervals. First thing, I want to go back to our definition. Let's slide on back to the definition. Increasing, we talked about earlier. Positive slope between 2 points. Decreasing, negative slope between 2 points. Let's talk about this graph. This graph has different slopes. Over here, this location over here, we're going to say that has a negative slope because it is going down from left to right. Now, the slope is constantly changing, but it's still always negative. Now, as we're going along, we got negative, 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 negative. Once we get to here, then it starts going up and we got a positive slope. Then we got a negative slope down here, and we got another positive slope over here. Now, changing the words from positive and negative to increasing and decreasing, that means this section over here is decreasing, this section over here is increasing, this section over here is decreasing, and this section over here is increasing. Okay, that's a lot. Let's figure out how to label that. So let's start off with just this first increasing interval. We're going to write this out. I'm going to write it one way and then show you how to write it the shorthand way. We're going to say it's between 2 points. It's increasing from this point to this point. So the left side of that left value, we identified it as negative 3.57. That was that x value of that minimum value. And for this purpose, I'm going to say, we're just going to use an inequality, is less than x, which is less than the left point, this guy over here. So we're going to use the x value from that high point there, which we calculated when we found the maximum value. It was negative 1.68. Let me shift this a little bit so it's not, my face isn't covering. Pardon me. So that is one way to write it. That's a lot of words. But let me just go through it again, or a lot of symbols, I should say. Let me just go through it again. This is saying that it is increasing for all x values that are between negative 3.57 and negative 1.68. So for example, if you were to choose negative 2, if you go over to x equals negative 2, and you'll see right there at x equals negative 2, it's increasing. It's got a positive slope going from left to right. And negative 3 is also between that. It's got a positive slope. Negative 2.5, negative 2.38, all of them have a positive slope in that range. Now that's a lot of writing. We're going to shorten this just a little bit. So the way we're going to shorten it is we're going to write, kind of looks like a coordinate, which can be a little bit confusing. We're going to use this later again, that might make things a little more clear. But we're going to make it kind of look like a coordinate. We're going to say the first number we're going to list is the left side of that bound, so that negative 3.57, and the right side is we're just going to write as the negative 1.68. This is the notation we're going to use for intervals. It's going to be the starting point and the ending point. Now, the other one that is increasing over here, it starts here, increases forever and ever and ever. So let's just write this as an inequality one more time. We're going to say it starts at x equals 0. It started right there. So 0 is less than x is less than, where does it stop? Oops, sorry, I'm covering with my face. Or my window, I should say. Where does that side stop? So it starts increasing at 0, it goes up, 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 forever. It's never going to stop. The way we express it not stopping is infinity. Now, using infinity in inequality is kind of weird. That's also another reason we go towards that shorthand notation. So we're going to say it starts at 0, ends at infinity. So it's increasing from 0 to infinity and beyond if you want to use Buzz Lightyear. But it's going to keep going forever and ever and ever and ever. As the x's get further and further away from 0, as it goes bigger and bigger and bigger, it's still going to be an increasing graph. Decreasing. Thinking about the inequalities for this left side here. Where's the left bound of that one? Where does it start on the left side? It doesn't. So we're going to say it's quote unquote starts at negative infinity is less than x, and it stops decreasing once it gets back to this point here, when we already determined that x value is negative 3.57. Again, the shorthand notation, which we're going to start using more and more and more. Let me just, here, I got an idea. Let me move my face. All right, I'm out of the way. So we're going to go use that shorthand notation. It's decreasing from negative infinity to negative 3.57. So as far to the left as you can think, and then even further than that. And then that's where it starts. And then it keeps going down, 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 until it hits that minimum point that we observed earlier. I just about pointed at the screen with my finger, and you wouldn't be able to see where I was pointing. The other one, it's decreasing. It starts decreasing from here. So it starts decreasing here and goes to there. So we're going to say, for this one, let's just try doing the final notation that we're going to use without using an inequality. It starts at negative 1.68. That was that x value of that maximum value that we had found there. And it ends at 0. So it's decreasing between negative 1.68 and 0. Okay, a couple more things we got to add to this. This is a longer problem. I don't even know how long this video is so far. Because it's so stinking long, I'm actually going to not have you watch the video for the second problem. I'm just going to have you look at the answer key, or try it on your own and look at the answer key. So just a little extra practice there. Let's see. End behavior is next up. I went out of order. End behavior. I'm going to do that over here. Remember, every end behavior is going to follow this pattern. It's going to say as x approaches, and if you have Mrs. Walker or if you have me, we actually do this in a slightly different order. My head's in the wrong spot again. We do this in a slightly different order, and they're both perfectly okay. It doesn't matter if you start with x equals negative infinity or x equals positive infinity, because you have to do both anyways. So I believe Mrs. Walker tends to list the positive infinity one first. I tend to list the negative infinity one first. Again, doesn't matter as long as you're describing it well. It's kind of like saying, well, it's like saying Mrs. Walker teaches second hour algebra 2 and I teach third hour algebra 2. It's like, does it matter if I say that I come first? Who cares? So as x approaches negative infinity, as we go further and further to the left on this graph, the function, in this case it's just called y, goes to positive infinity. So again, using that roller coaster analogy, if we're using the roller coaster analogy, if we're riding the roller coaster and going to the left, as our roller coaster is approaching negative infinity in the x-axis, it's going up and up and up. It's going to positive infinity on the y-axis. For the roller coaster that's going to positive infinity, so it's going to positive infinity on the x-axis. It's going up and up and up forever there as well. So we're going to say y approaches positive infinity. Domain and range. Domain, we're going to abbreviate with the letter D. Domain, we're going to use some notation here. Making sure I'm not getting ahead of myself. We're going to say x is, the first thing we got to do is use a fancy notation. This is not an E, it's an element symbol. So we're going to say x is an element, and I'm going to draw this fancy letter here. X is an element of the real numbers. What that means is every x value that I use is going to be a real number. And for that one, that's all we need to say. So it could be pi. I could plug in pi, 3.14159, etc., and I can get a y value. I can plug in 6. I can plug in -2. I can plug in 5,000,008,000, and it'll work. It's going to give me a really very big number if I plug in 5,000,008,000, but it'll work. And so that's all we're going to say. The range. This time we're talking about y values. Now looking at our graph, you'll see it's not going to go up forever and down forever. It exclusively goes up forever. It's got a low point. So we're still going to start off the same way, and this is a pattern we're going to use a lot this year. Our y values that we have, even though it's not every real value, they are real values. Every y value that we have is a real value. We're going to draw a bar here, and we're going to read this as x is an element of the reals. It's a very pretentious, fancy way of saying it. That bar is saying just as long as, or sometimes you'll hear mathematicians say, such that our y values are, in this case, they got to be greater than or equal to that lowest y value that we had. That's another reason we start finding local and local maxima and local minima. So going back to where we found our minimum points, the lowest minimum point that we had, it seems redundant, the minimum point, whatever, is that negative 3.12. So we're going to say all of our y values are greater than or equal to negative 3.12. That's saying our graph is never ever going to get below y of negative 3.12. So negative 3, perfect. Negative 3.2, no. Negative 3.13, nope. Negative 3.12, yep. Negative 3.11, yep. Just never below negative 3.12.